The oil drop experiment.
About the Monday night matchup. And finally, some movement on the...
This was Millikan's original experiment, and as you can see, it has this chamber right here where the oil falls through, and the atomizer shoots the oil in. What Millikan did was to put a charge on a tiny drop of oil and measure how strong an applied electric field had to be in order to stop the oil drop from falling. Since he was able to work out the mass of the oil drop and he could calculate the force of gravity on one drop, he could then determine the electric charge was always a multiple of negative 1.6 times 10 minus 19 degrees Celsius, charge on a single electron. This meant that it was electrons carrying this unit charge. We are doing the oil drop experiment. The oil drop experiment was performed by Robert A. Millikan in 1909. This experiment determined the size of the charge of the electron. This also determined that there was a smallest unit charge. We are making a stop-motion video. This allows us to move the oil drops and show their transformation throughout the experiment. We'll be using Play-Doh to represent the oil droplets as they fall. The green pipe cleaners are in the place of the radiation that is shot out onto the oil drops. Now when the oil drops eventually get a charge, the Play-Doh change to green to show that they now have a charge. The top of the drawing has sparkles, indicating the oil droplets produced by the atomizer. Some of these droplets fall through the hole in the upper landing. As the oil drops through the bottom chamber, they pick up a negative charge due to the X-rays. With this happening, the air starts to become ionized. This causes electrons from the X-rays to attach to the drops of oil. In this video, you will see the orange balls representing the oil drops, the red sparkles at the top representing the oil droplets produced by the atomizer, and the green pipe cleaners as the radiation that is shot out onto the oil drops. So I'll just play the video. And the green pieces of Play-Doh represent the oil drops changing and getting a charge. As you can see in this video, some of the droplets fall through the hole in the upper landing. As the oil drops through the bottom chamber, they pick up a negative charge due to the X-rays. With this happening, the air starts to become ionized. This causes the electrons from the X-rays to attach to the drops of oil. The drops that remain suspended in midair are balanced by the electromagnetic force and the force of gravity. That meant that voltage from the batteries attached to the bottom chamber were producing the right amount of voltage. Conclusion. The electron has a very small mass. He determined the size of the charge of the electron. He also determined there was a smallest unit charge, or the charge that is quantized.